guys, and welcome to Sifatuk Academy the Intellect on YouTube. In this channel, we are out here the advanced level science students to attain the academic excellence and the academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. In this video, in the demand of many people, we are looking at the Southwest 2024 advanced level mathematics paper 2 question 6 Roman 1, and the question is on curve analysis. So if you are new in this channel, I will invite you to subscribe to the channel and turn on the notification bell to not miss any of our videos subsequently uploaded. So the video is on curve sketching on the demand of many. Now this is our graph here. We are analyzing the graph. Now the first thing is that they say the graph below shows the curve of numerical function f of x in the xy coordinate plane. Now let's say state the domain of definition of a function, state the coordinates of the y-intercept, write the equation of the horizontal asymptote, and then draw the variation table of f of x. Now the first thing is that you analyze your graph. We are seeing here that this broken line here, first of all, broken lines on a graph means asymptotes. So if I have a broken line that is vertical, it means that automatically this is my vertical asymptote at the point where x equals to -1. I also see that when the graph is approaching this -1, it is avoiding when the graph is approaching this -1 here, it is avoiding the line -1. It is instead diverging. When the graph is leaving from this -1 here, as you are seeing, it's diverging to infinity. It's not touching this -1. Okay, and the same thing here. The graph is avoiding from -infinity now. It is avoiding the line -1, and it is increasing to to this one here. It is still avoiding this one. So and now it means that the horizontal asymptote will be at this line because it is broken and then it's horizontal there. So now the domain of the function is the restriction of that function. It means that it's where the point where the function cannot take the value x. At the only point that we see on our graph is the point where x is equals to -1. You're seeing that at the point x equals to -1, the curve avoids the line. So it means that the domain of our function will be what? X is an element of real number, and where x can not be equals to -1. And to write it into square bracket, we can have from -infinity to -1, and from 1 to +infinity. So this is our domain, this or this. But I prefer this because this one can help you much to have your variation table. Now the coordinates of the y-intercept. You know that the y-intercept occurs when x equals to 0. Now this is the line x equals to 0 here. Where does the curve touches the y-intercept or the y-axis when x equals to 0? Is at this point here. So it is at the point -1. So it means that the coordinate of the y-intercept is 0, -1. Now they say write the equation of the horizontal asymptote. This is our horizontal asymptote here because you are seeing that it's broken and it's horizontal, and it's at the point where y equals to 1. So our horizontal asymptote is at the point y equals to 1. So this is the equation of our horizontal asymptote. Now the D part of the question is we should draw the variation table of f of x. To draw the variation table of f of x, okay, first of all have our variation table like that. We have f prime of x, we have f of x. Okay, we have now our we spread out the domain, which is -infinity, we have -1, then we have +infinity. After that, after framing our variation table, we can now represent the vertical broken lines on the variation table, because the vertical asymptote is always represented on the vertical on the variation table. Now we are seeing that from the range from -infinity to 1. From -infinity to 1 here, you are seeing that the function is leaving -infinity, it increases to 1, so the function is increasing at that range. Now from the point -1 to +infinity, you are seeing that it is leaving -infinity and increasing to 1. Okay, so it means that it is also increasing in this range. Now the image of -infinity, you are seeing that the image of -infinity here is is 1. Okay, look at this 1. The image of -infinity is 1. So 1 is increasing to +infinity. This is our first graph. It is increasing to +infinity. Okay, now from above, you are seeing that -1 is -infinity. So the -infinity is now is increasing to 1. As you can see, the curve here is increasing to 1. Okay, so that is how we draw our variation table. So that was all for the analysis of this graph of the Southwest MOCK. So guys, you have come to the end of this video, and if the video is interesting to you, I'll invite you to subscribe to the video I'll invite you to like the video, subscribe to the channel, and turn on the notification bell to not miss any of our videos subsequently uploaded. And you can always tell us the video that you want us to do, and we'll do it immediately. So guys, not forgetting that in science, consistency is the key.